as you can see here, we are in the data portal website. You can see the address, the URL, and there is one tab that you can click, which is the Explore the EurOPDX data. This will bring you to the data portal. You have to register and log in. Of course, I had already registered. When you log in, typically the typical choice would be, for example, to use Google, to sign in with Google, but there are many options. So once you choose your option, you finally log in and enter the data portal. Now we are switching to the next video. Here we are in the data portal. There is a search field, but the most interesting part is the filter tabs that you can use. So for every type, you can see you can select data that have certain types of information you are interested in, or the source, so the single data set provided by the various centers. The access modalities, so samples that are available for transnational access or for collaboration. You can search for specific gene mutations if it's included and the type of variants you are interested in, or again, a gene that has copy number alterations. And there is a dedicated panel for breast cancer biomarkers. You can understand if the patients have been treated or not, if they are naive or not naive. The type of treatment of the patient, and when available, drug response of the PDX model. And then here is the type of cancer. Of course, here is the larger collection. As Emilia said, now we are concentrated on a more limited number of tumor types. Again, basic things like gender and age bins, where you can select tumors in younger or older patients. So in principle, you have a wide spectrum of possible filters to select the model of your interest. Now I'm going to present one possible way of selecting model through the data portal, in particular focusing on breast cancer. So we can start the next video. So now we try to concentrate, for example, on searching models for which we want to explore HER2 amplification and gene mutations available. So we can try to select from, for example, from the data set, say, I want samples for which there are gene mutation data. And we see we have more than 600 cases with gene mutation information. And then we select, like, for example, HER2, HER2 positive, okay? And when we come to this very selected system, we have 3 cases which have HER2 amplification and mutation information. Now let's say, well, I want to know in these genes which have p53 mutated. So we type, you see there is a system for helping you select the gene of interest. And there are a number of variants available, models with many different variants. And we just select all because we don't know what type of variant is included in the 3 models of interest, and you pick search. And out of this search, you can find one model that has p53 mutation and HER2 amplification. You click on the model ID, and in this way, you can see all the information available for that particular model. So the patient of origin, the age, the histology, the tissue, the grade, the stage, and the type of mouse in which it has been implanted and propagated. This is the basic information from the model, information about the patient of origin, and information about molecular data. So this is a link to directly see when are available mutation data from this model. So in this case, when you click here, you see all the mutations that have been detected in this model. So in addition to the one of interest, other things could actually be additional mutation that could be of interest. So in this way, through a number of criteria and annotation of the models, you can find one or more PDX models of interest for a specific project. I think we are close to the end exactly of this video. Okay, so this is one possible approach. The second is you can open but not launch the video. The second option is to use the data portal to select a subset of samples and build a cBioPortal view of these samples, so including molecular data that are available. I'm going to show this for colorectal cancer in this case. So we can start the video. So now in this case, for example, we want to take one entire study like data source. We can take the Candiolo Cancer Institute colorectal, click here, and it comes out that we have 600 models from this study. So it's a big study of colorectal cancer, a big set of models. And if you scroll down, you see on the bottom, export to cBioPortal. You click this button, and this brings you to another page, which is where you can track you click export data. So this is the description of the data set, and now you see a bar that is building. It takes some minutes because the system is building a cBioPortal instance, so it's creating the instance. The video I think stops here and then continues once you finish the process and all the procedure has been completed by the system. The page changes. Now you have a green button with cBioPortal, when you can click it, and now when you click it, you open the cBioPortal for the 639 samples of interest. There is some disclaimer. You just go through the disclaimers, and here we are in the EurOPDX cBioPortal. Now we build this study, IRCC, and you can select information of interest. I think the video is almost done here because there is then one video dedicated to the use of the cBioPortal to identify and select samples. And this is the last video. So now I have already written down genes of interest. This is particularly useful if you want to select genes of interest which are non-obvious. In this case, for example, I wrote IGF2 or B2, and how you can see, you just type the gene and there is a system that runs a check whether the gene symbol is okay. All gene symbols are valid, so you submit the query. And now we have the oncoprint, so the aggregate view of all the models. You can see how many samples you have per patient. In some cases, there are more PDX that have been profiled, even up to 3. And there is a color code for every sample. Every sample is a column, like IGF2 mutation. The red means amplification, or missense mutations are in green. Here you can see when you mouse over one of these features, it displays the information that is available. Okay, like in this case, there is MYC amplification, and so on. Like there is one sample here where you have ERB2, which is mutated, copy number amplified, and mRNA upregulated. So this is a sample, for example, where ERB2 is really high, really strong, mutated and amplified and overexpressed. You can, in this case, just by the oncoprint, go to identify the sample. This is the sample ID. You click on the sample ID, and in this way you can open the page from cBioPortal with information about the sample. So here you can see this sample has a total of 67 mutations. So of course, in addition to the ERB2 mutation, there are other mutations, and they are all reported here. This sample has only one copy number alteration described, and then you can click on clinical data and see the attributes. Also from here you can see information available from the samples, the age, and other information from the sample of origin and from the patient. So this is one way, directly from the OncoPrint. Another way is to use the plot function of cBioPortal. Here in this plot, can you stop it a little bit? Can you stop the video? It's going a little bit quick, and I need a moment to explain things here. So here on the x-axis, you don't see, but you see three categories: gene loss on the left, gene intermediate, normal copy number, and amplification on the right. And on the y-axis, we have mRNA expression of the gene of interest. You can restart the video, thanks. And here you can see that when you mouse over each individual gene, you can see details. You can change the gene of interest, like ERB2. When you click on ERB2, you can see there are some samples which have ERB2 amplification and overexpression. The green one also have a mutation. So you can directly select samples from the plot and do the same thing. When you mouse over, you will see information for each. This is MIC, and you can select one model of interest just by mousing over and clicking on the sample ID. And again, you open the page with all the information related to that sample. So in this case, again, this sample has a total of 92 mutations and copy number alterations, not only one, there is a second copy number alteration. Interesting is MAD4 deletion. So this model also has the TGF-beta pathway genetically inactivated, which could be maybe of interest, depending. So this is another way of selecting models, rather than based on their annotation, which is typically done on the data portal based on molecular profiles and molecular features, gene expression, copy number, and mutation. This is a typical approach of cBioPortal. So if you are familiar with the cBioPortal of the memorial with the main website, we are not doing anything different at this stage. There are profiles for mutations. For example, if you select ERB2, this is the distribution of mutations in the models of the entire colorectal cancer dataset. So you can browse here and select the mutations of interest, for example. This is another way of finding information, aggregate information on a data set and identify interesting model. Now, this of course has been done for the usual suspects, so I put ERB2, but if any investigator has a particular gene of interest, that gene of interest can be explored in the collection to find models that have alterations or deletion or amplifications or overexpressions. There is a lot of information that simply pops out from the mutation in terms of the functional consequences. And I think we are finished. You can run a mutual exclusivity analysis, for example, just to see whether these alterations tend to co-occur. Now, in this case, these three alterations do not have a significance co-occurrence. So there is a tendency to co-occurrence or to mutual exclusivity, but if you just select significant only, you will see that nothing comes out. So there is no significant either mutual exclusivity or co-occurrence of these alterations. And this is one classical way of exploiting the cBioPortal for complex queries on molecular profiles.